So next we define the notion of an atomic formula. An atomic formula is intuitively basically just anything that expresses equality or states a relation. So in fact that makes it very easy to define rigorously. An atomic formula is any equation of some two terms or a relation on the appropriate, I should probably down here have sub r, an appropriate number of terms in its argument. The set of formulas is more complicated. It could be sort of composed together with other logical connectives or operators, and so we define it recursively as the smallest set W such that it contains the atomic formulas, and then on top of that, that's the base case of the inductive definition. For the inductive case, we suppose that we have two things already established to be formulae, and then we require that any logical operation on them is also a member of the set. This set we call the set of L formulas, or just formulas for short. Some quick definitions: a variable is called free if it has no, if it is not within this operator, so to speak, so that it is not located inside of a sentence where the existential operator is on the outside of that sentence or formula. And if it is not free, then it is bounded. You might wonder, as I did when I was learning this subject, why we would even have this notion of a free variable. Like, why is that even something that we permit? Because after all, if a formula has no free variables, we call it a sentence. Sentences bear truth value, right? Can be true or false, but formulae cannot. So why do we even have a formula? And I would argue, for one thing, you can see it as a mapping from the terms in, or from the objects in the domain to the set true-false. So that's one perspective that might be a little bit insightful. And my other answer to the question, why have formulae at all, is that it's really just a sort of a device. It's helpful in stating theorems and whatnot, but on their own, I don't think formulae are per se interesting as opposed to sentences. So that's my answer to that, and we'll continue with definitions in the next video.